Hi there, and welcome to Activity 8 of Having Fun with Chemical Reactions. In this reaction, we're going to look at what happens when we put an acid and a base together. It's what's known as a neutralization reaction. Okay, so basically what happens? Well, firstly we get an acid and it reacts with a metal base, and as a result it becomes neutralized. Now let's just recap what is an acid. Well, an acid is H+. It's basically acidic. Because it's got lots of H+ ions, it is very reactive. Now a base is made up of OH- ions. It's basic. But when we put the two together, what we notice is, look, we've got a hydrogen on the left-hand side in red, and we've got another hydrogen in purple on the right-hand side of the plus sign. That's two hydrogens, and we've got an oxygen. Join those together, and the result is we've got two hydrogens joined with one oxygen, which is water. And we know that water is neutral. Now, what's left over then joins together. Now, normally what we end up with is a metal base, and it will join with the salt part of the acid. So the metal will join with the salt, so you get a metal salt. And then you get water. The only question now is, how much H+ and how much OH- ions do we have? If we have equal numbers, then the solution will become neutralized. We'll have equal amounts of H+ and equal amounts of OH-. However, if we've got too much acid, we've got too many H+ ions floating around and not enough OH- to join with them, then only a certain amount will make water, and the rest will be in the form of H+ ions, so as a result the solution will be acidic. And likewise for a basic solution where we've got too much base. So how can we test for whether it's neutral or not? Well, if we add a little bit of universal indicator, we will know, because if there's too many H+ ions, then the solution will go red. If there's too many OH- ions, then the solution will go blue to purple. If we get it just right, then the solution will go green, and we know that green is neutral. So as a result, we've got a way of determining whether the solution has gone neutral or not. Okay, so there's a generic equation that we can build up from this reaction. Again, these generic equations are the things that you really need to go away and learn. So, what do we need to know? Well, we start off with our reactants and our products. Now we're going to have an acid and then a metal base. We're always going to have the same in these neutralization reactions. So we have an acid and a metal base, and we stated that the metal from the metal base will join with the salt from the acid, and the acid in the base, the H+ and the OH-, will join together to make water. Okay? By adding a little bit of universal indicator, we can then determine whether the solution has been fully neutralized as to whether it turns green. Obviously, if it's blue, we've got too much base. If it's if it's red, then it's too much H+. By adding a little bit more of the one that we're deficient in, we'll get it more to a neutral reaction. So let's look at an example as to how we can use that generic equation. Well, in this example, we've got a base, magnesium hydroxide. Note that the hydroxide is the base part, and it's reacted with the acid, hydrochloric acid. Now remember, hydrochloric acid always produces the metal salt, metal chloride. So whatever the metal is will join with the acid to make the chloride. So we've got hydrochloric acid, which is joined with the base magnesium hydroxide. When they combine, we're going to get magnesium chloride, remember the chloride coming from the hydrochloric acid, and we get water. And as a result, we will hope that it's neutral by testing with universal indicator. Okay, if you look on the link below this video, you will see the video which will show an acid-base neutralization reaction. In this case, what we've got is a burette of acid, which is added to a base with some universal indicator, and you should see the color changing all the way through blue, all the way through to red. Then there are a set of questions on Activity 8 that you can work through using the generic equation. Again, it requires you to work through Word and chemical formulae, and then finishing off with your balanced equation. Also, it will ask you questions along the idea as to how do we test the neutralization reaction has occurred. Okay, I hope you've found this useful and you're happy to go away and look at our neutralization reactions. Good luck. Don't forget to check your answers on the answer sheets and join me again and we'll look at our next reaction. Thank you for watching.